All right, so this is chapter 12. This is the last chapter. In chapter 12, we're going to go back and review regression. Chapter 3 was regression. We needed to review some terms and definitions and, what least squares regression line mean and all that kind of stuff. But to start out, let's talk about the inference that we're going to do on regression analysis. So the question we're going to pose here is there an association between SAT writing scores and passing rate on AP exams at high schools in California? We have developed inference procedures for means, proportions, and counts. Now let's explore what happens when we take a sample of bivariate data and try to estimate the slope of the least squares regression line. All right, so we have a link here. This is a Google Docs of California SAT and AP scores data. So let's take a look at that. So this is all of the schools in California, I believe. There might be some missing, but we're just going to pretend it's all of them. I think there's like 1,152 of them or something. I don't know. I can't really scroll down very easily. I guess I could. I guess 1,123. Each of these is a high school. And we have the high school, the school district it's in, the city that it's in, the enrollment, and then these last two are the ones that we're going to take a look at. This is the average SAT writing score, and this is the percentage of passing grades that get on APs. APs passing is 3 or higher. It's sorted by AP grades, so these schools are the lowest. There's only a 3% passing rate here. If you go down to the bottom, we get up to these 90% pass rates, okay? So what we want to do is, this is too many schools. Let's take a sample of schools, or pretend we don't have this information, and we want to take a sample of schools and see if there's a relationship between SAT writing scores and pass rate. All right, so in this activity, we're going to explore whether there's a positive association between SAT scores and pass rate. You would think a school that has higher SAT scores would have a higher percentage of kids passing. If there is an association, then what is the slope of the least squares regression line? So let's let beta, the Greek letter beta, be the true population slope of the regression line between scores and passing rate for all kids, for all high schools in the state of California, and B be the slope of the sample regression line between SAT scores and AP pass rate for the sample of 15 schools. If there is, in fact, a positive association, then we would expect our beta to be greater than 0. If we don't have census data from the population, we only have a sample, we'll eventually learn how to run a linear regression t-test for slope. This is what we're going to do this chapter to determine if we have enough evidence. We will learn the mechanics of this later, but for right now, basically what we're going to do here, and I'm sorry, the directions here don't make a whole lot of sense, but we're going to take a sample of the slope, and we're going to take a sample of high schools, and then we're going to calculate the sample slope. And then we're going to see, does this sample slope give us enough information to perhaps conclude that the population slope is maybe positive. So our null hypothesis is going to be that beta is equal to 0. That is, there is no association between SAT scores and AP pass rate, versus the alternate that beta is positive, meaning there is a positive association. To determine if we have enough evidence, we must explore the distribution of our sample slopes. This is really what this activity is all about. So we did this in class. It's not going to have the same effect as doing it in a video, but I am going to just perform it. I'm going to take a simple random sample of 15 schools. So I'm not going to, I've already kind of done it, but probability, random integer. I want to generate random integers between 1 and 1, 1, 2, 3, and I want to generate 15 of them. Now, if there are any repeats in this list, we'd have to generate an extra one and throw out the repeat. So what we want to do is we want to copy these numbers onto our spreadsheet. So if we go to this example, I put in a different set of numbers. Let's say I ran those numbers and these were the numbers here. So when you put in a 1, it goes back to this sheet and looks for Pop 1, which is Aspire Golden State College Prep, and it records the school, the county, and then the 2 pieces of information that we're looking for. So this is it for our sample of 15. And what this program does is it calculates the computer output at the bottom, and it even makes a scatter plot for us so we can see the relationship. Okay? So as you can see, looks like there is a bit of a positive relationship, quite a bit of scatter, so maybe not real strong. And here's the computer output. Here's the standard error of the residuals. Here's the R-squared value. Describe the association for your sample. So we're going to take a look at this example. So I would say there's a positive. I would say it's linear. And I'm going to say moderate. So I'm going to say there is a moderate positive linear association between SAT scores and AP pass rate. For the schools in the sample. The issue is this is just a sample of 15. Just because we see kind of a moderately strong relationship here, maybe we just got lucky with this 15 and it kind of looks like this. Maybe in the population of interest, there's random scatter, or maybe there's even a negative association. That's the questions we're going to kind of ask and attempt to answer with probability models this unit. Write the least squares regression line. So if you recall the constant, this is my y-intercept and this is my slope. So my predicted AP score, AP rate, pass rate, is going to be my, let's go negative 111.8, negative 111.8 plus my slope, 0.2361, 0.236 times the SAT score. So this would be the equation of my linear model. Find and interpret the standard deviation of the residuals. That is this value here, 13.45. Standard deviation of the residuals, kind of like my standard error in my predictions, kind of. I can't remember what it was. 13 point, let's say 13.5. And using a linear model with SAT to predict AP pass rate. So this is just kind of my setup. I use this a lot in some of the interpretations. Our predictions are predicted our AP pass rate predictions, let's say it like that. Our AP pass rate predictions will typically be 13.5 percent points away from the true pass rate of the school, AP pass rate. So I might predict that the school passes 40% of their AP tests, but on average, I'm going to be 13.5 points away. Maybe I'm 5 points away, maybe I'm 20 points away, but on average, about 13.5. Find and interpret the coefficient of determination. That's the R-squared value. That is 67, we'll just call it 68%. So the same kind of can statement at the start. when using when using a linear model with SAT scores to predict AP pass rate, 68% of the variability in your Y variable in AP pass rate is accounted for by this model. Meaning only 32% of the variability is, 38% of the variability is left unexplained. So 68% of the variability in pass rate is accounted for by the model, leaving 32% into other variables. And there could be any number of things. Where it's located, financial, like economic status of the school, what type of kids they have, where, big city, countries, all the other variables that could possibly influence pass rate. Copy the sample slope you got right here. Okay, so my sample slope was 0.236. And that would be in the units, change in Y over change in X. That's your slope, right? That would be percentage points per SAT point. Basically, for every one SAT point the school goes up on average, their percent passing rate goes up by 0.24%. Yeah, 0.24%. What's your best guess for the true population slope? Well, my best guess would obviously be the only guess I have. This is the only information I have, so that's my best guess for beta. Now, I know it's probably not the right beta. It's probably not exactly the right value, but hopefully it's going to be pretty close. Does this provide any evidence of a positive association? Yes, of course it does. Explain. Well, I don't have to say well. The sample slope is positive. So perhaps the population slope is positive. That would seem to make sense, right? That would be my best guess anyway. What are two explanations for why the sample slope you got in 2 is positive and not equal to 0? Well, we've done this before. One possibility is the true population slope beta is 0, meaning there's no positive association, and we got a positive sample slope because of chance sampling variability. Meaning, I should have gotten a 0. If I did it once, I might get a positive 0.1, and if I did it again, I might get a negative 0.2, and if I did it again, I might get a positive 0.25. So, half the time we're going to get over 0, and half the time we're getting under. So maybe this is just one of those times where we got over. Chance variation. Or 2, the true slope beta is positive, and we got a positive sample slope because of that. We got a positive sample slope because we got a value near beta, which was positive. So if beta is in fact positive, maybe it's 0.4, then it makes sense that I would get